In this video, we want to talk about quotient rule. So let's say we have a function that says fx equals x over x minus 1. So how can you find the derivative of this function? Well, the formula for quotient rule is f prime x equals gx f prime x minus fx g prime x all over gx all to the power of 2. Here is the formula for quotient rule. So let's use this formula here to solve this function. So first things first, let us label our function. So we call the top fx, we call the bottom gx. So f prime x equals the derivative of x is 1, open parenthesis, x minus 1, close parenthesis, minus the derivative of x minus 1 is 1, open parenthesis, x, close parenthesis, which is all over x minus 1 all to the power of 2, which equals x minus 1 minus x all over, open parenthesis, x minus 1 all to the power of 2. X cancels x, so we are left with negative 1 over, open parenthesis, x minus 1 all to the power of 2. And this is our final answer for this question. So let's take another question. So let's say we have a question that says fx equals e to the power of x all over 2x minus x plus 1. So first things first, we label, call the top fx, call the bottom gx. So our formula f prime x equals the derivative of e to the x is still e to the x, followed by the bottom function 2x minus x plus 1, close parenthesis, minus the derivative of 2x minus x plus 1 is 2 minus 1. Let's put this here. Open parenthesis, e to the power of x, close parenthesis, all over, sorry, I think there's a mix up here. So let me just call this squared and let me leave this way. So I would like to rewrite this derivative here. There's an error in the question. I take that back. So the derivative of the bottom function is, we have this to be EX, open parenthesis, we have 4x minus 1, close parenthesis, all over, open parenthesis, 2x squared minus x plus 1, all to the power of 2. So we can move further by opening the parenthesis, of which we can say e to the power of x multiplied by 2x to the power of 2. We have 2x to the power of 2 e to the x minus x e to the x plus e to the x minus 4x e to the x plus e to the x all over what we still have at the bottom, 2x squared minus x plus 1 all to the power of 2. So we can see that e to the x is common at the top among everything. So to make things easy for us, we can easily factorize the top, of which we have e to the x outside, open parenthesis, 2x to the power of 2 minus x plus 1 minus 4x plus 1. And also, we can also collect the like terms. Close parenthesis, all over, open parenthesis, 2x squared minus x plus 1, all to the power of 2. So finally, we have e to the power of x, open parenthesis. So we have 2x to the power of 2, negative x, negative 4x. We have negative 5x. One plus 1, of course, we know is 2. Close parenthesis, all over, open parenthesis, 2x to the power of 2 minus x plus 1, all to the power of 2, which gives us this as our final answer. So as you can see, this is a little bit demanding. You really need to be very, very careful with the signs and how you factorize this expression. So let's move further to another question. Okay, let me just do some cleanups here. Let's do some wrap up. So let's take a trigonometric question at this point. We have fx equals sine of x over sine, sorry, not sine, I take that back. over cos of x. So we can call the top fx, we can call the bottom gx as usual. So f prime x equals cos x, which is our gx. So our fx, which is sine x, the derivative of sine x is cos x minus the derivative of cos x is negative sine x. So all over cos square x. You can also say cos x all to the parentheses raised to the power of 2. Or you can write cos square x. They're still the same thing. So what I'm trying to say is that cos square x is the same thing as cos x all to the power of 2. So let's move further by doing some algebra. So cos x multiplied by cos x, we have cos square x. Negative multiplied by negative, of course, we have a positive. We have sine square x all over cos square x. Now we have the trig identity of the top is 1 over cos square x. But this is not the end. The trig identity of what we have here is nothing but sec square x. And this is the final answer for this problem. Now, this problem right here can be solved in another way. I would like to make use of a space here so we can see the difference. Let's say we have the same question that says fx equals sine x over cos x. Now, sine x over cos x has its own identity. We can write sine x over cos x as tan x. So in this case, the derivative of tan x is what? The derivative of tan x is nothing but sec square x. Of course, we can see the answer at the bottom here. We just proved it. So it's either you do it this way or you do it this way. Just have it at the back of your mind that tan x tan x equals sine x over cos x. Just keep it in mind that way. So let's move to the next question. Okay, let's do some cleanups here. And we can handle another question. So let's say we have a question that says x squared minus x plus 1 over 2x minus 3. Now, in this case, how can we solve this question? Remember, don't be confused. It's still the same thing as fx equals x squared minus x plus 1 over 2x minus 3. They're still the same thing. So how can we solve this question? So first things first, we label this as fx. We call this gx. And of course, f prime x equals, we have the top, which is 2x minus 1, open parenthesis, 2x minus 3, minus, we have 2, open parenthesis, x squared minus x plus 1, close parenthesis, all over, open parenthesis, 2x minus 3, all to the power of 2. So we can open the parentheses above. 2x multiplied by 2x, we have 4x squared minus 6x minus 2x plus 3. So we have negative 2 multiplied by x squared, we have negative 2x squared plus 2x negative 2 all over, open parenthesis, 2x minus 3 all to the power of 2. And of course, I think we have like terms here. Let's see. I think there is an error with our, okay, I bet there's no error. So let's move further ahead. So 4x squared minus 2x squared, we have 2x squared. Negative 6x, negative 2x, we have negative 8x. We also have plus 2x, and we have 3 minus 2, which is plus 1, all over, open parentheses, 2x minus 3 all to the power of 2. And of course, our final answer becomes 2x squared negative 6x plus 1 all over, open parentheses, 2x minus 3 all to the power of 2. And that's the final answer for this problem. Let's see if you can take one last problem. All right, so let's say we have something so different. Let's say we have a question that looks like this. Fx equals um 3x to the power of 3 plus 2x to the power of 2 plus 1 all over 3x squared. So at this point, we have fx, we have gx. So let's say this f prime x, we have gx first, 3x squared. The derivative of the top function is nothing but 9x to the power of 2 plus 4x, close parentheses, minus the derivative of the bottom function is 6x, open parentheses, 3x to the power of 3 plus 2x to the power of 2 plus 1 all over 3x to the power of 2 all to the power of 2. So we have 27x to the power of 4 plus 12x to the power of 3 we have 18x to the power of 4. We have negative 12x to the power of 3. We also have negative 6x all over. We have 3x to the power of 4. Now, I can see we have like terms. So 12x to the power of 3 cancels 12x to the power of 3. Do we have any other like terms here? I don't think we have it. So let's do some algebra here. So 27x to the power of 4 minus 18x to the power of 4 is 9x to the power of 4. Minus 6x all over 3x to the power of 4. Now, is this our final answer? Of course not. We can either divide through or we factorize. So whichever one we want to do is fine. So let us divide through. So by dividing through, we have 9x to the power of 4 over 3x to the power of 4 minus 6x over 3x to the power of 4. It is this way, okay. So x to the power of 4, x to the power of 4, 3 here 1, 3 here 3. We have 1x here. We have 3x left at the bottom. 3 here 1, 3 here 2. So at the end of it all, we are left with 3 minus 2 over x to the power of 3. And this is our final answer at this point. So let me give you some exercise for you to do. Okay. So whenever you're dealing with questions like this, please, I will advise that you take your time, because any error you make will affect others. And you need to be very, very careful when it comes to dealing with negative signs, because it can make the whole of the expression wrong. So just be careful with your negative signs, okay? So let's see some exercise here. So number 1, fx equals radical of x over x plus 2. Number 2, fx equals the square root rather, x plus 1 over x 3. Fx equals cos x over sine of x. Number 4, we have fx equals 4e to the x over the square root of 2x plus 2. And the final one, number 5, we have fx equals x cubed over 2x to the power of 4 plus x to the power of 3. So that is it for this video.